Hello students, in this video we shall study problems on Newton's interpolation formula. First problem, find y of 1.4 by using suitable interpolation formula given the table which contains x and y. Solution, here we have to find y of 1.4, that is we have to find the value of y at x equal to 1.4. And in this table, x equal to 1.4 lies near to the beginning of the table. So we shall use Newton's forward interpolation formula. First, we construct the difference table as below. Here, x values are 1, 2, 3, 4 and 5. Y values are, y values are given as 10, 26, 58, 112, 194. Now we write first difference. 26 minus 10, which is 16. 58 minus 26, which is 32. 112 minus 58, which is 54. 194 minus 112, which is 82. Now we write second difference in similar pattern. 32 minus 16 is 16. 54 minus 32 is 22. 82 minus 54 is 28. Now the third difference again, 22 minus 16 is 6. 28 minus 22 is 6. Fourth difference, 6 minus 6 is 0. Since the given problem has 5 points, we may get at the maximum of fourth difference. For Newton's forward interpolation problems, we use the values of difference table which is at the top of the each column. So from the table, y naught value is 10, y naught value is 10, x naught is 1, delta y naught is 16, delta square y naught is 16, delta cube y naught is 6, delta to the power 4 y naught is 0. All are the topmost values of each column. So we have Newton's forward interpolation formula y equal to f of x, which is given by y naught plus r times delta y naught plus r into r minus 1 times whole divided by 2 factorial delta square y naught plus r into r minus 1 into r minus 2 whole divided by 3 factorial delta cube y naught plus r into r minus 1 into r minus 2 into r minus 3 whole divided by 4 factorial multiplied by delta to the power 4 y naught. We call this equation as star. Here r is given by x minus x naught whole divided by h, where x naught is the initial value of x, which is 1, which is 1. H is 1. H is 1. H is nothing but x1 minus x naught, x1 minus x naught, that is 2 minus 1 is 1, or it is also equal to x2 minus x1, 3 minus 2. So h value is 1. So x is the point at which y value is required, that is x is 1.4. So we get r as 1.4 minus 1 divided by 1, which is equal to 0.4. Therefore, equation star becomes y equal to f of 1.4 equal to y naught is 10, r is 0.4, delta y naught is 16 plus r is 0.4, r minus 1 is 0.4 minus 1 divided by 2 factorial is 2. delta square y naught is 16 plus r into r minus 1 into r minus 2, that is zero point 0.4 into zero point 0.4 minus 1 into zero point 0.4 minus 2 whole divided by 6, that is 3 factorial, into delta cube y naught is 6 plus delta to the power 4 y naught is 0. So it comes out to be 14.864. Thus y of 1.4 value is 14.864. Now the second problem. The following table give the values of f of x equal to y, which is equal to tan x, for x lying between zero point 0.1 and zero point 0.3. Find tan of 0.26. Students, here we have to find the value of y at x equal to 0.26, and x equal to 0.26 lies near to the end of the table. So we have to use Newton's backward interpolation formula. First we construct a difference table as below. X values are 0.1, 0.15, 0.2, 0.25, zero point 0.3, and y values are 0.1003, 0.1511, 0.2027, 0.2553, 0.3093. Now we write the first difference. 0.1511 minus 0.1003 is 0.0508. 0.2027 minus 0.1511 is 0.0516. 0.2553 minus 0.2027 is 0.0526, and 0.3093 minus 0.2553 is 0.0540. Now we write the second difference similarly. 0.0516 minus 0.0508 is comes out to be 0.0008. 0.0526 minus 0.0516 comes out to be 0.001. 0.0540 minus 0.0526 is comes out to be 0.0014. The third difference, which is again easy, 0.001 minus 0.0008 is 0.0002. 0.0014 minus 0.001 is 0.0004, and the last difference, fourth difference, is 0.0004 minus 0.0002 is comes out to be 0.0002. Since we have 5 values of x and y, we may get the maximum of fourth difference. Since we are using Newton's backward interpolation formula, the required values for the formulas are at the bottom of the each column. That is, yn is 0.3093, xn is 0.3, del yn is 0.0540, del square yn is 0.0014, del cube yn is 0.0004, del 4yn is 0.0002. Now we have Newton's backward interpolation formula. Y equal to f of x, which is equal to yn plus r times del yn plus r into r plus 1 whole divided by 2 factorial del square yn plus r into r plus 1 into r plus 2 whole divided by 3 factorial del cube yn plus r into r plus 1 into r plus 2 into r plus 3 whole divided by 4 factorial del to the power 4 yn. We call this equation as star, where r is given by x minus xn divided by h. X is the point at which y value is required, which is 0.26, minus xn is zero point 0.3, divided by h value. H value is calculated by using the formula x1 minus x0 or x2 minus x1. So 0.15 minus zero point 0.1 is comes out to be 0.05. So R value is 0.26 minus zero point 0.3 divided by 0.05, which is minus zero point 0.8. Now substituting all these values in equation star, we get y equal to f of 0.26, which is equal to yn is 0.3093 plus r is minus zero point 0.8, del yn is 0.0540 plus r into r plus 1, that becomes minus zero point 0.8 into minus zero point 0.8 plus 1 divided by 2 factorial is 2. Del square yn is 0.0014 plus r into r plus 1 into r plus 2 is minus zero point 0.8 into minus zero point 0.8 plus 1 into minus zero point 0.8 plus 2 whole divided by 3 factorial, which is 6, multiplied by del cube yn, which is 0.0004 plus r into r plus 1 r plus 2 into r plus 3 becomes minus zero point 0.8 into minus zero point 0.8 plus 1 into minus zero point 0.8 plus 2 into minus zero point 0.8 plus 3 whole divided by 4 factorial, which is 24, into del to the power 4 yn, which is 0.0002. After simplifying, we get 0.2660. Thus, the value of y of 0.26 is 0.2660. Third problem. Find the value of f of 38 and f of 85 using suitable interpolation formula for the following values. X and y values are given. So, we have to find f of 38. Finding f of 38 is nothing but we have to find the value of y at x equal to 38, which lies near to the beginning of the table here. So we use Newton's forward interpolation formula. Also, we have to find f of 85, that is, we have to find y at x equal to 85, which lies near to the end of the table. So, in that case, we use Newton's backward interpolation formula. First, we construct the difference table as follows. X and y values are given. The x values are 40, 50, 60, 70, 80, 90. So h value is a 10. Y values are given as 184, 204, 226, 250, 276, 304. Now we write the first difference. 204 minus 184 is 20. I hope you know the pattern. 226 minus 204 is 22. 250 minus 226 is 24. 276 minus 250 is 26. 304 minus 276 is 28. Now the second difference, similarly, 22 minus 20 is 2. 24 minus 22 is also 2. 26 minus 24 is 2. 28 minus 26 is also 2. Now the third difference, 2 minus 2 is 0. 2 minus 2 is 0. 2 minus 2 is 0. For Newton's forward interpolation formula, we require the values which is at the top of each column. That is, y0 is 184, x0 is 40, delta y0 is 20, delta square y0 is 2, delta cube y naught is 0. Similarly, for Newton's backward interpolation formula, the values are xn is 90, yn is 304, del yn is 28, del square yn is 2, del cube yn is 0, and h is 10. First we find f of 38. To find f of 38, students, we have to use Newton's forward interpolation formula, which is given by y equal to y naught plus r times delta y naught plus r into r minus 1 whole divided by 2 factorial delta square y naught plus r into r minus 1 r minus 2 divided by 3 factorial multiplied by delta cube y naught. Call this equation as star. We call this equation as star, where r is given by x minus x naught divided by h, where x is the point at which y value is required, that is 38. X naught is first value of x, that is 40, h is 10. So 38 minus 40 by 10, we get r as 0.2 minus 0.2. Substitute r delta y naught del square y naught del cube y naught in equation star. We get y equal to f of 38, y naught is 184 plus r is minus 0.2, delta y naught is 20 plus r is minus 0.2, r minus 1 becomes minus 1.2 by 2 factorial is 2, delta square y naught is 2 plus r into r minus 1 into r minus 2 becomes minus 0.2 minus 1.2 minus 2.2 whole divided by 6 multiplied by delta cube y naught is 0, which comes out to be 180.24. Thus the value of f of 38 is 180.24. To find f of 85, we have to use Newton's backward interpolation formula, which is given by y equal to f of x, which is equal to yn plus r times del yn plus r into r plus 1 by 2 factorial multiplied by delta del square yn plus r into r plus 1 into r plus 2 whole divided by 3 factorial multiplied by del cube yn. Call this equation as double star, where we have to again find r, which is given by x minus xn divided by h. X is the point at which y value is required, which is 85. Xn is last value of x, which is 90, divided by 10. So 85 minus 90 by 10, which comes out to be minus 0.5. Now substituting r del yn del square yn del cube yn in equation double star, we get y equal to f of 85 is equal to 289.75. We will continue the problems in our next video. Thank you.